Okay, so we are on 7.4 basic trig equations. So remember an identity, a trig identity like sine squared plus cosine squared equals 1 is true for all values of x. No matter what x is, it's always going to be true. You can pick anything and plug it in and it'll work. However, a conditional trig equation will only be true for some values of the variable x. So conditional statements are statements that you get an answer, you solve an equation, you get an answer, and it's only true for a limited number of values. It could be infinite, right? But it's not for all of them. So consider the equation sine of theta equals 1/2. How many solutions will this equation have? Well, look at the graph. So this purple graph right here is the graph of sine, right? And then the green line is the graph of y equals 1/2. And how many solutions will this have? Well, there's a solution, there's a solution, there's a solution, there's a solution, there's a solution. There's an infinite number of solutions where sine is 1/2. So you might think that you can just take the inverse sine of both sides, right? Like when you're solving in a calculator, to get theta by itself, you do the inverse. However, how many solutions does that have? So inverse sine of 1/2, right? We have sine can only be right here. Inverse sine can only be in the first or the fourth quadrants. And so sine is 1/2 just right there. So theta in this case is only pi over 6. But if you look up at our graph, it's pi over 6, it's another one, and another one. There are a whole bunch of them. So to find all solutions where your sine is 1/2, so let's make our little picture. Sine is positive 1/2 right here, and sine is positive 1/2 right here. Those angle values are pi over 6 and 5 pi over 6. But what if I go around the circle again? So I start here and I go all the way around and I hit pi over 6 again. Or I keep going and I hit 5 pi over 6 again. Or I keep going over and over and over and over, right? There's an infinite number of solutions. Just like up here, you have one here and here and here and here and here and so on and so on and so on. So to find all the solutions, you're going to get theta equals pi over 6 plus 2 pi k. So that's all of the solutions that end up right here. That's all the times that sine is 1/2. But we also have 5 pi over 6 plus 2 pi k. And that's all the times that sine is 1/2 right here. So this would be your answer for all of the solutions to the equation. So taking the inverse is not the same as solving the equation. You are doing the inverse, but you're not doing the inverse function of sine. You're just trying to find everywhere where that happens. So let's look at the next one. Solve the equation tangent theta equals negative root 3. So hopefully we memorized this by now, but if not, we'll still work on it. Tangent is root 3 right here. Oh, no, it's not. I guess I need to still work on it. Tangent is root 3 right here. So this angle is pi over 3. Tangent is negative in the fourth quadrant. So this is, 5 pi over 3. But it's also negative in the second quadrant, 2 pi over 3. Since we're not doing inverses, we are not restricting our circle to just the two quadrants. So I'm going to look for my first answer, theta equals 2 pi over 3, and then look and see where I get to the next one. So if I'm starting at 2 pi over 3 to get to the next one, I just have to add pi, right? And then to get to the next one again, I add pi again and again and again and again. So for tangent, because the period is just pi, you only have to add pi to get to the next one. So it's 2 pi over 3 plus pi k. But what about this one where I have a restriction to my angle? It says the angle has to stay in between 0 and 2 pi. So I can't just add pi k to it, right? I'm going to get theta equals 2 pi over 3. And then it also equals 5 pi over 3. Whoop. Sorry about that. 5. Oh my gosh. It's not liking me today. 5 pi. I don't know why it's doing that. Anyway, that's a pi. So theta is 2 pi over 3 and 5 pi over 3. Those are the only places that it happens if it's in between 0 and 2 pi. So We could ask for all solutions, right? So solve the following equation. We just want to find all the solutions. Or we can restrict it and we want to say we solve that equation within that domain. By the way, these notes are not on OneDrive. They'll be on OneDrive after I do them in class, but I wanted you guys, if you were going to copy down the notes, I want you to actually watch the video to copy them down. But once we do them in class tomorrow, they'll be on the OneDrive, so you'll have them. All right, so we have another example. Solve the following equation. 2 cosine squared theta minus 1 equals 0. So if you thought about 2x squared minus 1 equals 0, we'd solve that equation by adding 1, dividing by 2, square rooting both sides, right? So same idea here. 2 cosine squared theta equals 1. So cosine squared theta equals 1/2. Square root, cosine theta equals plus or minus, plus or minus the square root of 1 over 2. That doesn't look exactly like something, so we have plus or minus 1 over root 2, looking better, which is plus or minus root 2 over 2. So now we want to know, when is the cosine of theta positive or negative root 2 over 2? Well, that's going to happen at all 4 of our 45-degree angles. So it happens at pi over 4, it happens at 3 pi over 4, it happens at 5 pi over 4, and it happens at 7 pi over 4. Since we're doing plus or minus, it's going to include all of those. We don't have a restricted domain, so when we solve this, we want to know all of the places. So it's going to equal pi over 4 plus, that's a 45-degree angle, right? So pi over 2 times k. Pi over 2 times 1, pi over 2 times 2, pi over 2 times 3, 4, 5, 6, 7. So this is my answer. All right, let's see. Okay, we can keep going. These aren't going to be too long. Okay, so again, we have another quadratic looking problem. 2 secant squared theta plus 3 secant theta minus 2. So we're going to factor it. 2 secant theta with something, and then secant theta with something. So we need factors of negative 4 that subtract to be 3. So it needs to be 4 and 1, right? Positive 3, so this is our plus, this is our minus, equals 0. So just like you would factor 2x squared plus 3x minus 2 equals 0. So if you need to go over there and do that with a quadratic, you can. You could do use substitution with this if you wanted, but really you should get to the point where you can just factor them using the words. So 2 factors set equal to 0, one of them has to be 0. So 2 secant theta minus 1 equals 0, or secant theta plus 2 equals 0. Move it over, so secant theta equals 1/2, which means the cosine of theta equals 2. Secant theta equals negative 2, which means the cosine of theta equals negative 1/2. So, cosine of theta equals 2. That means theta, even though we don't really do it like this, would be the inverse cosine of 2. Now, what's the problem with that? The problem is this ratio is bigger than 1, right? So the cosine of theta will never equal 2, so that one doesn't work. When is your cosine negative 1/2? Well, it's negative 1/2 right here and right here. It doesn't tell me any sort of restrictions on the domain, so I'm going to say theta equals 2 pi over 3. Whoa, sorry about that. It just went crazy. Yikes. Okay, so theta equals 2 pi over 3 b over 3. And then to get to it again, we have to add 2 pi k. So plus 2 pi k. And then our next one is 4 pi over 3 plus 2 pi k. So those are my answers for this one. All right, I feel like I'm really going fast through these. We're right at 10 minutes. Let me see. We only have... Oh, we have 2 more pages. Okay, so I'm going to stop this one, upload it, and then I will do the next one.